Fermi said he was smarter than Galileo. Then he vanished and was never found. A man walked into my laboratory in Rome when he was 21 years old. He looked at a calculation I had been struggling with for days. He left without saying a word. The next morning, he came back with the answer, scribbled on the back of a cigarette package. He had solved it during the streetcar ride to the university. I knew then that I was dealing with a mind I could not explain, and I have spent my career explaining things. His name was Ettore Majorana. He predicted the neutron before anyone and refused to publish. He predicted particles that physicists are still searching for a century later. He made me feel like a student in my own laboratory, and then, on March 25th, 1938, he boarded a boat and vanished. He never arrived at his destination. His body was never found. I begged Mussolini to search. The Italian Navy searched. His family searched. Nothing. No body. No letter. No trace. I said to my wife, Ettore was too intelligent. If he has decided to disappear, no one will be able to find him. My name is Enrico Fermi. I won the Nobel Prize for Physics. But the man I just described considered the Nobel Prize banal. Via Panisperna, number 89. That was the address of the most important physics laboratory in Italy. The young men who worked there were Segre, Amaldi, Rossetti, and Pontecorvo. The newspapers called us the Via Panisperna Boys. We were building something new. We were taking apart the atom. Majorana had been studying engineering, but Emilio Segre had convinced him to switch to physics. From his first day, we all knew something was different about him. It was not just the speed. Everyone in our group was fast. It was what he did after he solved something. He threw it away. Literally. He would scribble a result on a scrap of paper, show it to no one, and drop it in the trash. I once found a calculation in his wastebasket that contained a result I had never seen before. When I confronted him about it, he shrugged. He said, "It is nothing. It is obvious." That was Majorana. He looked at his own brilliance the way you might look at a glass of water. Useful, perhaps, but certainly not interesting. He once told me, "Everything that can be understood is banal." That sentence would haunt me for the rest of my life, because I could not tell whether it was the most arrogant thing a physicist had ever said, or the most honest. In early 1932, news arrived from Paris. Frédéric Joliot and Irene Curie had discovered something extraordinary, a neutral particle that could enter matter and knock protons out of atoms. They concluded it must be a very energetic photon, because at the time, the photon was the only known particle without a charge. Majorana read their results and saw what no one else could see. He came to me and explained it with perfect clarity. The particle could not be a photon. To move something as heavy as a proton, you need something equally heavy. The particle must be neutral and must have approximately the same mass as a proton. A completely new particle. He had just predicted the existence of the neutron, the particle that holds every atom in the universe together. Without neutrons, you would not exist. I told him to publish immediately. He refused. He said it was trivial. I argued with him. I pleaded. He would not listen. Months later, James Chadwick proved the existence of the neutron experimentally. Chadwick received the Nobel Prize. Majorana could have had it. When he heard about Chadwick's discovery, he reportedly said, "Great, now I do not have to write anything." He saw the neutron the way you see the ground beneath your feet, so self-evident that pointing it out felt beneath him. It was magnificent, and it was terrifying. I urged him to leave Italy. In January 1933, he traveled to Leipzig to work with Werner Heisenberg, and something I never expected happened. Majorana made a friend, his only friend. In letters he wrote afterward, he called Heisenberg not just a colleague, but a warm personal friend. From the man who spoke to almost no one, this was extraordinary. Heisenberg convinced Majorana to publish a paper on nuclear exchange forces, something I had never managed to do. The paper went further than Heisenberg's own work. It was one of only 9 papers Majorana would ever publish in his entire life. But when he returned to Rome, the man I knew was gone. Chronic gastritis, nervous exhaustion. He stopped coming to the laboratory. He stopped seeing anyone. For nearly 4 years, Ettore Majorana disappeared from physics, not yet from the Earth. That would come later. In January 1938, he resurfaced. He accepted a full professorship at the University of Naples, given without examination because the Italian government declared his expertise too singular to be tested. He began teaching. His lectures were brilliant, but almost incomprehensible. He seemed restless, unhappy, and then, in March, he emptied his bank account, all of his savings, every lira. On the 25th of March, he sent a letter to Antonio Corelli, the director of the Physics Institute in Naples. The letter said he had made a decision that had become unavoidable. There is not a bit of selfishness in it. He asked forgiveness for betraying the trust and the sincere friendship given to him. He wrote that he would keep a fond memory of them at least until 11 p.m. tonight, possibly later too. That night, he boarded a steamship from Naples to Palermo. The next morning, from Palermo, he sent a telegram that said, "Do not worry about what I wrote. Tomorrow, I will return." He then sent a second letter saying the sea has refused me, and I shall return tomorrow. The first letter reads like a farewell. The second cancels it. The sea has refused me. Does that mean he tried to jump and failed, or something else entirely? He was confirmed aboard the return ship from Palermo to Naples the following evening. A professor from the University of Palermo, Michele Strazzeri, shared his compartment. He never arrived in Naples. He was never seen again. I went directly to the highest authority I could reach. I stood before Mussolini and told him, "There are several categories of scientists in the world. Those of second or third rank do their best but never get very far. Then there is the first rank, those who make important discoveries. But then there are the geniuses, like Galileo and Newton. Majorana was one of these. You must search for him." Mussolini ordered the search. The Italian Navy was deployed. The police investigated. The family offered a reward of 30,000 lire. They searched the sea. They searched the hospitals. They searched the monasteries. Nothing. No body. No record of a death. No trace. I told my wife Laura, if Ettore has decided to disappear, he is smart enough to do it. But that did not stop me from hoping. Every week I expected a letter, a phone call, a sighting, something. It never came. And here is what tormented me most. The letters contradicted each other. He emptied his bank account. But why would a man planning to die withdraw his savings? His family said he was a devout Catholic, and the church forbids suicide. His confessor, Monsignor Riccieri, told a colleague years later that Majorana had experienced what he called mystical crises. But bound by the seal of confession, he could say no more. I spent the rest of my life not knowing whether he was alive in a monastery somewhere, praying, not knowing whether he had drowned in the dark water between Palermo and Naples, not knowing whether he had calculated, with the same precision he applied to everything, that his own disappearance was the only equation left worth solving. But there is something I have not told you yet, something that may be the key to everything. During those 4 silent years, between 1933 and 1937, when the world thought Majorana had stopped working, he had not stopped. His mind never stopped. In 1937, the year before he vanished, he published one last paper, his 9th. And what was inside it haunts me to this day. Dirac had predicted antimatter, that every particle has a mirror with the opposite charge. Majorana asked a question that none of us had dared to ask. What if some particles are their own mirror? What if a particle and its antiparticle are the same thing? A thing that is simultaneously itself and its own opposite. These particles are now called Majorana fermions. They may explain the dark matter of the universe, the invisible mass that holds galaxies together but that no instrument has ever detected. And in 2025, Microsoft named its first quantum computing chip Majorana 1 because the future of computing may depend on the particles he predicted. One paper, 14 pages, written by a man who had been silent for 4 years, and it may reshape our understanding of the universe. Now think about the timeline. He publishes this paper, a paper about particles that exist as their own shadow, their own opposite, their own mirror, and months later, he becomes exactly that. A man who is simultaneously present and absent, Who writes a farewell and then cancels it? Who boards a ship and never arrives? Who may be dead and may be alive? Who is, in some terrible sense, his own antiparticle? I have never been able to separate the physics from the disappearance. I do not think they can be separated. The theories multiplied over the decades. Some believed he took his own life. Others said he retreated to a monastery, seeking the silence he had always craved. The writer Leonardo Sciascia was convinced that Majorana had foreseen the atomic bomb, that he understood, years before anyone else, that nuclear physics would lead to a weapon of unimaginable destruction, and chose to vanish rather than participate. Sciascia's theory is poetic, but I have to be honest, for a genius like Majorana, it is not impossible. And then, in 2015, the Italian authorities announced something remarkable. They had investigated a witness who claimed to have met Majorana in Venezuela in the 1950s, a shy, quiet man who went by the name Beanie and refused to be photographed. A single photograph was obtained and analyzed. The authorities concluded that the man was likely Majorana. They found evidence he had maintained contact with his uncle, the physicist Quirino Majorana, under a false name. The case was officially closed. Majorana had chosen to disappear. He had emigrated to South America. He had lived. But no one knows why. No one knows what he saw. In the equations, in the future, in himself. That made him decide to leave everything behind. Fermi said he was smarter than Galileo. Then he vanished and was never found. In his short career, Ettore Majorana published 9 papers. He predicted the neutron and refused to claim it. He built a theory of nuclear forces that surpassed Heisenberg's. He proposed particles that are their own antiparticles, particles that may explain the dark matter of the universe and power the quantum computers of the future. And then he disappeared. I won the Nobel Prize in 1938. The same year, Majorana vanished. I stood on that stage in Stockholm, and somewhere in the back of my mind, I thought of him. Of the man who could have been there instead of me. Of the man who would have looked at the prize the way he looked at everything, as something banal, something obvious, something not worth the trouble. He was 31 years old when he disappeared. He left behind 9 papers, a crumpled cigarette package, and a question that physics has never been able to answer. Not a question about particles. Not a question about equations. What did Ettore Majorana see that made him walk away from everything? I spent the rest of my life trying to answer it. I never could. Some truths, it seems, are visible only to the kind of mind that considers them obvious.